All right, folks. So here we are again. Today's about graphing and evaluating functions and equations. Okay. So first thing is you'll need a calculator, whether it's on your Chromebook or your personal calculator. If you have graph paper to take notes, this would be a good time because this is going to be some graphing. Or there's a blank copy of these notes you can also use if you want to just follow along the video and things like that. Okay. So functions and graphing. So the first thing I'm going to tell you is this. If you don't remember the difference between a function and a relation, that's okay. A relation is sets of points, which means that your example 1 and 2 that you see on your screen are relations. Okay. What makes them functions is that they follow a what we call one-to-one relationship. And what that means is that if you pick an x value on any one of these graphs, it's going to give you only one y value. Okay. And in a second, I'll show you what a non-function looks like with example 3. But this first part of it is just knowing how to create a table from your graph, how to write it, and then make sure you put it in the correct order. Okay. All right. So first thing is this. Know that your x and your x values go together. Know that your y and your y values go together. Okay. That's going to be very important here in a second. Okay. So let's get into this. When I write these tables, know that there's no right or wrong way in terms of which points you use, but there is a right or wrong way in terms of how you write them. Okay, since it's a table, we want to make sure we put our x's with our x's and our y's with our y's. Now, when I do this, I'm going to pick certain points every single time because when I start graphing later on, these are the kind of points you want to graph as you go forward. So, like for example, there are 2 points I see right away I'm going to pick. I want to pick this point, and it's not going to pop up again for some reason. And I'm going to pick this point. Okay. Oh my God. This is starting to annoy me just a little bit. Okay. Whatever. I'm going to pick the 2 x-intercepts, which is going to be, it looks like, negative 5, 0. And 1, 0. Okay. I'm also going to pick the point here, which looks like it's 0, 2. I'm going to pick this point, which it looks like is negative 2, 6. And then I'm going to pick a random point like this point right here, which looks like it's 2, negative 2. All right. So the reason why I picked these 2 points is because those are our x-intercepts. Okay. And the reason why I picked this point is because that happens to be our y-intercept. Okay. This point right here, I picked it because later on when we start working with absolute value, we're going to call this our vertex. Okay. And then the other point is just kind of a random point that I picked. So when I write these, I make sure that the points and coordinates that I use, the x value goes with the x, the y goes with the y. So the first question is asking is this a function? Well, if I look at my x values, for all my x values, they all produce just one single y value. Okay. It's what we call a vertical line test, sort of. Since it does not double up anywhere, this is what we call a function. Okay, so yes, it's a relation, but it is a function because of the relationship of the points. Okay. And the second thing it's going to ask you is this continuous or discrete? Well, because this is an actual line that is being drawn like this, then we know this is what we call continuous for that exact reason. Okay. So if I move over to the next graph, first thing is before I start filling out the table is this. Notice how these points, none of these are connected by a line. Okay. For that reason, right off the bat, we know this is what we consider to be discrete because it's just those 5 points that we're worried about. Okay. Working a little bit backwards, is this considered a function? And again, if I look at these, they all point to a single y value. So in this case, it's also what we call one-to-one. Okay. So now to pick points, the difference between what I just did a minute ago is that I could have picked any point along this blue line, whereas on this graph, the example 2 graph, I can only pick those 5 points to write down. So like the first one, is going to be, looks like -4, -4. The second one looks like it's going to be -2, -3. Then we have 0, looks like -2. Then it looks like we have a 2, -1, and then a 4, 0. And again, if I look at the points, this is my y-intercept, which is 0, -2. And then I have my x-intercept, which is 4, 0. Okay. So that's one thing you're going to do quite often this year, regardless of what function we have, is be able to graph and fill out tables for those functions. Most of what we deal with are functions, so that's kind of nice. Okay. So moving on to example 3. And again, if you want to pause at this point to try to fill out the table, go for it. Okay, I'm back again. So if you filled out the table, then you should have, and again, depending which points you picked, but again, I'm going to pick this point, I'll pick this point, I'll pick this point, I'm going to pick this point, and then I guess just to make it even, I'll pick this point right there. So if I do that, that looks like it's 0, 1. Looks like it's 3, 0. Looks like it's 4, -1. It looks like it's 3, -2. And then it looks like it's 0, -3. Okay. So here's the thing. A minute ago, I said it's what we call a one-to-one function, okay, for it to be considered a function. However, if you notice this point and this point, okay, what's happening is this. We have an x value of 3, which is giving us a y value of 0 and a y value of -2. Well, because of this is actually not a function at all. This is actually just what we call a relation. Okay, so everything's a relation, only certain things are functions. They have to meet that requirement. Okay, this is considered continuous still, either way. Okay, if I did my vertical line test, again, if I picked from here to here, it also goes here to here. So see how it's here and here. There's 2 points it actually touches. Same thing here, same thing here. Okay, that's also why it's not considered a function. My x-intercept, we're going to have 3, 0. And it looks like we're going to have, actually that's it, just 3, 0. My y-intercept looks like we're going to have 0, 1. And it looks like we're going to have 0, -3. Now notice, because there are 2 y-intercepts, that right there is kind of a telltale that says it's not going to be a function. Okay, so before I move on to where this is all going to lead to, I want to do a quick review of what is evaluation. Now, if you know how to do this, again, pause at this moment, try it out, see if you get what I get. Okay, so f of 5. Here's what this means. If I drew a table, this is my x, this is my f of x, okay, also known as y. When we see f of 5, that basically means what is y when x is equal to 5. And so if I plug this in, I'm going to make sure and drop it in and substitute for my x. So if I write this out, this will be 3 times 5 minus 4 plus 2. And if I do some math, again, use your calculator, this will be 15 minus 4, which is 11. So square root of 11 plus 2. And because I know this is going to be a decimal, I'm going to go ahead and tell you now, when we do decimals in this class, we're going to round to 3 decimal spots. So when I do this in my calculator, it looks like I get 5.317. Okay. So when we talk about evaluation, that's what we're talking about. Okay. So moving on to the next example. Don't want to do that. Don't want to do that. Don't want to do that. down here. Okay. Now, you want to pause at this point and try to fill out this table by yourself. You can. Okay, here we go. So again, notice that there are no values for x anywhere. So at this point, you can put whatever points you want. So I'm going to pick, let's see, I don't actually know what this is going to look like yet. So for sure, I'm going to pick 0. And that's going to give me my y-intercept here in a second. For sure, I'm going to pick, I'll just go with, let's look like 1. Let's look at 2. Let's look at -1 and -2. And this is probably going to give me what I want in terms of that. So if I plug these in, I'm not going to do every single one of these, but basically you would do -1/2 times -2 plus 3, and that would give me the y value that I'm looking for. Okay. I'm going to go through every single one of these. So at this point, if you want to pause it to kind of get your answers down, you can. Okay. So when you do this, it looks like you should get 4, 3.5, 3, 2.5, and 2. Now I'm going to go one step further, and I'm going to figure out that if I use 6, that's going to give me my 0. And I did that because I know that I'm going to need my x-intercept at some point. Okay. Now there's a different way of finding your x-intercept, but for right now, you can kind of guess and check until you get there. But if I look at my pattern from here to here, I can kind of tell where my y-intercept is going to probably end up being at. Okay. So if I graph these, here's 0, 3, here's 6, 0, and I'm not going to graph every single point on here, but I know it's a straight line like this. Okay. Yeah, this is going to be an ugly line. Watch. Yeah, it's not too bad. Anyway, so why did I draw a line as if it's continuous? Well, mainly because it doesn't actually tell you it's discrete. If it would have been a discrete graph, I would have only put these points and that's it. So it would have looked kind of like example 2. But because it doesn't actually tell me that, I'm going to make it continuous like example 1. Okay. So now, if you want to try example 5, you can at this point. Again, pause. And then once you've got your table in, you can kind of get an idea as to what you want to do. Now this time the points are given to you, so in the next lesson you'll see how a different way you can do this besides doing it this way, but again, you want to learn how to do it both ways. So once you've got your table filled out, you should get 5. Oops, I'm just going to zoom in real quick. You should get 5. You should get 0. That's important right there. That's my x-intercept. -3, -4, -3, 0, and 5, and I'm missing 1, 12. Okay. Don't ask where that came from because I don't know. And again, if I graph these, I'm not going to put every single point down right now because just trying to get one point in here is a pain. Put this one right here down, and then I think I'm going to put -3, -4 down. And again, that's going to end up being what we call a vertex later on. And there's my graph. Okay. And again, why did I draw a line instead of just the points? It's again because it doesn't actually tell me it's discrete. So I'm going to draw a line until I'm told otherwise. But my x-intercept, here's an x-intercept. I'm not going to write them all out right now. Here's an x-intercept. Here's a y-intercept. And again, when we get into a little bit later on, this is what we call a vertex point. And you'll see that in a whole different unit as well. So, all right. So if you have any questions, feel free to ask. If not, so what you have next is you have an assignment with some different problems, kind of like the example notes like this. Then you have a task card, which are both due today. And then again, if you have any questions, I'll be on Zoom at the scheduled time for questions. And we'll go from that point on. All right. See you around.